Hello, everyone, and welcome to Wednesday. This would be April 8th assignment, week 2, day 2. We're going to do a couple of simplifying roots problems. We've done a little bit of this before, maybe not to this extent, but we're still going to be using the same property that we've been talking about in this entire chapter. At the very end before we left is this thing here. X to the m over n is the same thing as writing it as the nth root of x to the m power. So I'm actually going to practice doing this, going from one to the other, and then simplifying it from there. Now, there's a long way of doing this, and we can go through and showing you all the steps, but I'm actually going to show you the short version of how to do all these problems. Hopefully you understand it as we go through. If not, you just maybe need to practice a little bit and maybe rewatch the video. So I'm going to show you kind of the short way of how to do these rather than doing the long way and rewriting it multiple times and as short as number of steps as possible. So let's rewrite this using that first property. Usually we can keep going with these simplification problems as long as the top number is bigger than the bottom number. As you see, 11 over 5, 6 over 4, 14 over 4. You'll see that that's a pretty common theme in order to keep simplifying these problems. So I'm going to rewrite it like the property that says up there. So that means the 5 that's on the bottom here is going to be on the outside. So it's going to be the fifth root of x to the 11th power. Now, in order to simplify this any further, what we look at is the power, and we compare that to the root number. Now, the root number is 5, and we ask ourselves, okay, well, 5 goes into 11 how many times? So if you think about counting by 5s, you have 5, 10, 15, right? The multiples of 5. How many times does 5 go into 11? Well, there's 1, 2. Wow. 2. You can't go up to 3 because 11 sits in between 10 and 15. So if there's 2 sets of 5 that goes into x to the 11th, that means we can bring out 2 x's. Not 2x, but as a power, it's x squared. All right, so this is kind of the new thing, kind of the shortcut of how to do this. 5 goes into 11 2 times. We represent that by putting x squared on the outside, and then we rewrite what we have times the fifth root. And now the question is, what do we have left on the inside? Well, when we said how many times does 5 go into 11, we got 10, right? It's 10. So how many would be left if there was 11 in there total? We technically took out 10. We did not take out 2. Every set of 5 that we took out ended up being given us 2. So we actually took out 5 and then 5 more. So there's actually 1 left on the inside. So I know it looks weird because we have x squared on the outside, but we actually took out technically 10 x's from the inside. But when it goes through the root, it comes out as just 1 set of 5. So every set of 5 that comes out is 1 on the outside. Hopefully that makes a little bit of sense. It just takes some time and practice to do it. So we're going to do a couple more just like that. So if you look at 2, this one we might say, well, 6 and 4 can actually be reduced before we actually change it, and that is true. So maybe I will do that first. If you want to reduce 6 over 4, it makes it a little easier. So y to the what power? Well, they both can be divided by 2. So that's 3 over 2. Divide them both by 2. And then we can use a property where we change it up here to the root. So this would be the square root. I would recommend putting the 2 there. Square root of y to the third. And then you ask yourself, how many times does 2 go into 3? If you list out your multiples of 2, it's 2, 4, so on, 6. So you can only really do 2 into 3 only one time. So that means 1y is going to come out, y to the first power. Then how many would be left on the inside here when you have a square root? Man, it's not doing so well. Okay, square root of how many y's? Well, 2 goes into 3 one time. 2 of them came out, so there should be only 1 left. So this would be y to the first times the square root of y. You can also write it like this, y times the square root of y. You don't need the first powers, and you also don't need to write the 2. All right, for the third one, you can kind of do the same thing, follow the same thing as number 2. We can actually reduce 14 over 4. Just allows us to use less numbers, I guess, overall. So 14 over 4 is the same thing as dividing both by 2, 7 over 2. So again, we have a square root. So this is square root of z to the 7th. Then you ask yourself, how many times does 2 go into 7? Just count by 2s. 2, 4, 6. 2, 4, 6. 2, 4, 6, 8. You have to stop there. So 2, 4, 6, that's 3 sets. Z to the 3rd times the square root. How many are left? Well, this went in for 2 to 6, and 6 of them came out. So that means there's only 1 left on the inside. So it just depends. Sometimes there can be more than 1, but so far we've actually only seen it come out to be 1 left on the inside. All right, number 3, very similar to the ones above. We just have multiple variables to deal with, and they already kind of did the first step for us. We don't have to rewrite it with the root because it already gives us the root. We have the cube root. A to the 4th, B to the 9th, C to the 15th. Just do one thing at a time. Leave yourself some space when you do it, and it's not really not that bad. We do it one thing at a time. 3 goes into 4. So A to the 1st. 3 goes into 4 one time. How many times does 3 go into 9? That would be 3 times. 3, 6, 9. So 3 times. How many times does 3 go into 15? That would be 5 times. So C to the 5th. These are all on the outside of the radical. Now we can start writing the radical times the 3rd root of what? Now let's go back and see what we have left. So if 3 goes into 4 one time, how many are left in there? Well, 3 goes into 4 and it gives you 3, so there's only 1 A left. 3 goes into 9 perfectly. So 3 goes into 9 perfectly, so there's nothing left. So there's no B's. 3 goes into 15 as well perfectly. 3, 6, 9, 12, 15. So there's no C's. This is actually your answer. I could even shorten this a little bit. So everything on the outside is A to the 1st, B cubed, C to the 5th times the cube root of A. All right, we got one more, and it actually has a number in it. This is kind of like what we did on Monday, but it's a little easier because this is actually on your chart. If you look at the 4th root of 81, that should be on your chart. So bring it up. 4th root here, 81. If you don't know it already, you can look at the table. It is 3. So we can reduce this to just be the number 3 on the outside. Nothing's on the inside as far as a number is concerned. That's taken care of. Then we do the same thing as we did the last set. How many times does 4 go into 10? That would be 2 times. So x squared comes on the outside. How many times does 4 go into 16? That goes in perfectly 4 times. 4, 8, 12, 16. So 4 times. Then what do we have left inside the radical? 4th root of, that was taken care of. 4 goes into 10 2 times. How many are left over? Well, if it goes in twice, that gives you up to 8. So you technically took 8 out. That means there's going to be 2 left. X squared. Oh no. X squared. And then 4 goes into 16. Well, it goes in perfectly, so there's no y's left on the inside. So that would be your final answer here. Because the only way to actually take something else out is you'd have to have at least 4 of them. 4 does not go into 2, so that's your final answer. 3x squared times y to the 4th times the 4th root of x squared. So there should be some problems you can try down below, kind of a similar idea. If you have any questions, you can always send a message on Remind or email me as well. All right, I'll see you next week.